Good morning, students. So we have been discussing the different external communication interfaces which can be used in an embedded system. Okay. So let us today discuss one more such type of communication interface, that is Bluetooth. Okay. So this Bluetooth is a wireless technology. So Bluetooth is a wireless, low cost, low power, okay, and short range communication technology which can be used for communication between an embedded system and any other external peripheral. Okay, so this Bluetooth, it uses 2.4 gigahertz of radio spectrum. So it works with this frequency, 2.4 gigahertz of radio spectrum. Okay, and it uses the technology that is called as frequency hopping spread spectrum. So Bluetooth uses frequency hopping spread spectrum, and the data rate that is available in case of Bluetooth is from 1 Mbps to 24 Mbps, and the range supported by Bluetooth is from 30 feet up to maximum 100 feet. Okay, so this is the range that is supported for Bluetooth communication. So this Bluetooth supports point to point and point to multipoint communication. That is, point to point means one device can communicate with another device directly, or there is a multicasting. One device can send the data simultaneous to number of devices. That is called point to multipoint communication. So these two are the two types of communication that is possible in case of your Bluetooth. Okay. Now whenever any two devices get connected via Bluetooth, then it is called as a Piconet. Then Bluetooth network is called as a Piconet, and in Piconet the maximum there can be up to 7 devices. Okay, so in a Bluetooth network which is called as a Piconet, there can be maximum only up to 7 devices which can get connected to the Bluetooth network. So any Bluetooth, suppose any device wants to implement a Bluetooth, it should have two parts. One is hardware, other one is the software. The hardware part is called as Bluetooth radio. Okay, the hardware unit that sends and receives radio signals is called as a Bluetooth radio. And also any Bluetooth device, it needs a protocol, so that is called as a Bluetooth protocol. So this Bluetooth protocol will be placed inside the Bluetooth IC of any Bluetooth enabled the device. Okay, so these two are required for Bluetooth communication, hardware as well as the software. Okay, so this is all about your Bluetooth communication. Okay, remember it is a wireless, okay, low cost, low power communication technology. Now let us go to one more type of external communication technology, that is called as wireless fidelity, or short form we call it as Wi-Fi. Okay, so as the name itself suggests, it is also a wireless technology. This Wi-Fi is wireless technology. Now for implementing wireless technology, this Wi-Fi, okay, so we need what, a wireless Wi-Fi router or wireless access point that is required. Okay, so as you might have seen in some public places or in railway stations, there is a wireless router placed somewhere. Okay, so when you go near to that wireless router, okay, you will get a wireless signal. Okay, so that is why for using Wi-Fi we need a router, Wi-Fi router or a wireless access point. Okay, so this router is responsible for managing the whole Wi-Fi network. It initializes the Wi-Fi network, and it also assigns IP addresses to the different devices, okay, which wants to communicate by using this Wi-Fi. Okay, then this Wi-Fi, it works in the range of 2.4 gigahertz or 5 gigahertz of the radio spectrum. Okay, so this is the range of frequency that is used by the Wi-Fi technology, and the data communication rate that is supported in Wi-Fi is, it ranges from 1 Mbps up to maximum 1300 Mbps. Okay, and the range of this Wi-Fi signal transmission is from 100 feet to 1000 feet maximum. Okay, now how to use this Wi-Fi? Okay, so whenever there is an wireless access point or a router, okay, when any other device that wants to use this Wi-Fi network, it should come within the range of this Wi-Fi signal. So when any external device that wants to communicate using this Wi-Fi, okay, when it enters that particular range, within the range, then this, when the Wi-Fi is enabled or it is switched on in this device, in this device all the available SSIDs, service set identifiers, will be listed here. So when the particular this Wi-Fi SSID is selected, then if it is a password protected, then you have to enter the password here, then the access will be granted to this Wi-Fi network. So in this way, how to communicate using Wi-Fi? When the particular device enters the Wi-Fi signal range, we have to switch on that, select that particular service set identifier SSID. For every Wi-Fi network there will be SSID. So you have to select whichever Wi-Fi network you want to connect, then enter the password, then you will be allowed to communicate using that Wi-Fi signal. This is how the Wi-Fi communication takes place. So as you can see here, this is wireless access point, WAP. Okay, then these are the devices which can communicate by using wireless technology with this, through this wireless access point or WAP. Okay, and the another type of external communication interface which can be used in an embedded system is ZigBee. Okay, so this ZigBee is also a wireless, okay, low cost and low power communication technology which is suitable for short range only. Okay, so this ZigBee is a low power, low cost, again short range communication technology which can be used in an embedded system. This ZigBee uses the frequency band of 2.4 GHz to 2.484 GHz of the radio spectrum, and the range that is supported in case of ZigBee is up to maximum 100 meters. The distance, maximum distance between any two devices communicating using ZigBee can be up to 100 meters, and the data rate is very low compared to Wi-Fi and Bluetooth. Here the data rate of the ZigBee network varies from 20 kilobits per second to 250 kilobits per second. So the data rate of the ZigBee network is quite low compared to Wi-Fi and your Bluetooth. Okay, so in any Wi-Fi, any ZigBee network will look like this. It will have three types of devices. In a ZigBee network, there will be three types of devices. The first one is called as ZigBee coordinator. Okay, this green colored one, this is called as a ZigBee coordinator. So this is the main device that is responsible for initializing or starting this ZigBee network, and it maintains all the information of the ZigBee network. That is called as ZigBee coordinator. Then we have blue colored devices, they are called as ZigBee routers. These ZigBee routers. Okay, so each ZigBee router will be connected to its neighboring other devices. Okay, so as you can see, this is connected to this router, this is connected to this coordinator, and this is connected to this router again. Okay, so these ZigBee routers are responsible for sending the data of one ZigBee device to another ZigBee device. Okay, and the third one type of devices that are present in a ZigBee network are the end devices. These red colored devices, they are called as end devices. They will get connected to a ZigBee router, or they will get connected to a ZigBee coordinator. Directly any two ZigBee end devices, they cannot communicate. Okay, they have to send their data either to the ZigBee router, or they have to send their data either through the ZigBee coordinator. Okay, but remember, any two ZigBee devices directly they cannot communicate. Either the communication has to happen through the ZigBee router, or the communication has to take place through this ZigBee coordinator. Okay, so remember, there will be three types of devices in a ZigBee network. Okay, ZigBee coordinator, these blue colored ones are ZigBee routers, and these red colored devices are ZigBee end devices. Okay, which can be your electrical switch, ZigBee enabled electrical switch. Okay, like that. So here is an example showing how to use a ZigBee network. Okay, so this ZigBee is mainly used for home automation, industrial control applications, and for data collection in case of medical field. Okay, so the home automation is shown here. Okay, in this diagram you are seeing how the ZigBee can be implemented for home automation. Okay, so as you can see here, there are number of switches here which are ZigBee enabled switches. Okay, and these are the lights corresponding to these switches. Okay, now there is no physical wiring between these switches and these lights. There is no wiring, but in our normal house, as you can see, from the switch there will be a wiring to this lights. Okay, but in a ZigBee enabled home automation system, there will be simply ZigBee enabled switches on the walls, but there is no electrical wiring between this switch and this light. Okay, so this is how the ZigBee enabled home automation looks like. There will be centrally there is the ZigBee coordinator, as I told you, which is the main unit of your ZigBee network. Okay, so here these lights or electrical appliances, they are connected to the main power supply through a switch. So this switch is also a ZigBee enabled switch. As you can see here, ZigBee enabled switches are there. Okay, so but there is no connection between this main electrical wire and these switches. There is no connection. They are independent. Okay. So whenever I want to switch on any of the light here, then I will press this button. Okay. When I press this button, this ZigBee enabled switch will send a signal, wireless signal to the coordinator, ZigBee coordinator. This in turn will send a signal to this ZigBee enabled switch, and it is going to be connected here. So then this light will turn on. Okay. So from here, it is the signal is being sent to this switch here through this ZigBee coordinator. Okay. So this bulb will have a ZigBee enabled switch here. Okay. So here, this is how the signal transmission takes place in case of a ZigBee enabled home automation system. Okay. This is one simple example showing how we can use ZigBee for our home automation. Okay. Then this is another example showing, okay, how to collect the medical information or medical data, and we can monitor those parameters, okay, in a patient. Okay. So as you can see here, this is the person of whom I want to collect the medical information. So this person is wearing some device, ZigBee enabled devices, which can monitor heartbeat, okay, and glucose level, okay, and body temperature like this. This person is wearing some ZigBee devices which can monitor different parameters related to his health. Okay. So wirelessly, these signals, measured parameters will be sent to the ZigBee coordinator here again. Okay. And this coordinator will send that data through this. There is one gateway through the internet to the computer of the doctor, the physician who is having the internet enabled computer. To this computer, the parameters which are measured by this ZigBee enabled devices will be sent through this coordinator, through this gateway to the physician, so that the physician can wirelessly monitor the different parameters of the patient, and he can take further course of action, okay, for maintaining the health of this patient. Okay. This is how we can use again ZigBee for monitoring the different critical parameters of the patient here. Okay. So the general characteristics of ZigBee are like this. Okay. So this ZigBee architecture uses low power for its working. Okay. The power consumption is very less. Okay. So as you can see here, the ZigBee enabled devices can operate for number of years after a single charge. Okay. After a single charge battery, the ZigBee devices, they consume very less power, hence they are capable of working for number of years without any battery replacement. Okay. So this is one of the advantage of using ZigBee devices or ZigBee network, because the ZigBee devices consume very low power. Okay. But then the next characteristics is the ZigBee data transmission rate. As I told you, it varies from 20 kbps up to maximum 250 kbps. Okay. But as we have seen in Wi-Fi, the data rate is up to 11 Mbps, or it can vary up to 1000 Mbps, whereas in case of Bluetooth, the data rate is up to 1 Mbps. So when compared to these two, Wi-Fi and Bluetooth, the data transfer rate in case of ZigBee is very less, 20 kbps to 250 kbps. Okay. And the range supported by this ZigBee technology is up to 100 meters maximum, 75 to 100 meters indoor within the indoor building, or when you go outside, the maximum distance can be up to 300 meters. Okay. This is the range that is supported by the ZigBee technology. Then whenever any device that wants to get connected to a existing ZigBee network, the joining time is up to 30 milliseconds. Okay. But whereas in case of Wi-Fi, any device that wants to get connected to a Wi-Fi network, it takes up to 3 seconds. Okay. For a Wi-Fi network. For a Bluetooth network, it takes up to 10 seconds. Okay. So as you can see here, the ZigBee network, any device that wants to get connected to a ZigBee network, okay, so it will take up to 30 milliseconds. Okay. So it is very small compared to the Wi-Fi and Bluetooth. Okay. And also this ZigBee networks, they allow up to 65,000 devices to be connected in a network. That is theoretically. But practically, up to 240 devices can get connected to a single ZigBee network. Okay. For example, in home automation, I can connect up to 240 different ZigBee enabled devices to my network in a home, like that. So the maximum devices that can be connected in a ZigBee network is up to 240 practically. Theoretically, 65,000 devices can get connected to a ZigBee network. But when you compare this number 240 devices practical in case of ZigBee network. With Wi-Fi, as you can see here, the Wi-Fi network allows up to only 32 devices in a Wi-Fi network, whereas in case of Bluetooth it is still low. It is only up to 7 devices can exist in a Piconet. The Bluetooth network is called as a Piconet. Okay, so in a Bluetooth network there can be maximum up to only 7 devices, and there can be up to only 32 devices in a Wi-Fi network. When you compare these two, in ZigBee it is very high, that is 240 devices can get connected in a ZigBee network. Okay, so this ZigBee, it can be used for low cost products, and it is very cheap for implementation. Okay, so it is a low powered, low cost communication technology. Okay, so and also the protocol used is open source, that is anybody can see what is there inside the software, protocol, communication rules, and if you want you can modify them. Okay, so it is an open source protocol, and the technology is also very simple for implementing. Okay, so these are some of the general characteristics of your ZigBee network. Then this ZigBee network, it allows 3 types of connectivity. One is called as star topology. Okay, the topology means how these nodes, different nodes or different devices are connected. So this is one type of connection that is possible in case of a ZigBee network architecture. Okay, so there will be centrally a ZigBee coordinator. Okay, then the end devices will get connected to this ZigBee coordinator. Okay, these end devices directly they cannot communicate, they have to go through the ZigBee coordinator here. So this is called a star topology, where there will be centrally there is a ZigBee coordinator and the end devices will get connected to the ZigBee coordinator. Okay, this is how we can use a ZigBee, we can set up a ZigBee network. Another type of connectivity that is possible in case of a ZigBee network is we can connect the devices in a mesh topology. Okay, so as you can see here, there is a ZigBee coordinator, this blue colored are ZigBee routers. Okay, and to these routers end devices are connected. Okay, now suppose here in this mesh topology, if this is the end device is A, this end device A wants to send some device to this end device B, so this will send the data to this router will send the data to this router. So in this way the data flows. Now suppose there is some problem with this router goes down. Now there is alternate path available, this device can send the data through this router, through this, like this to this. Okay, so in a mesh topology, if any of the intermediate router goes down, then alternate path can be used for data transmission. Okay, so the data transmission will not be affected in case of your mesh topology. This is another type of connection I can set up using ZigBee networks or ZigBee devices. Okay, and the third one is called as tree topology. It is very similar to your mesh topology. There is a ZigBee coordinator here at the center. Okay, in the tree fashion there will be branches, and each branch will have ZigBee router. Okay, and to this routers end devices will be connected. Okay, so if any device wants to communicate, they can communicate using, if these two devices wants to communicate, they will communicate through this router, and if this device wants to communicate with this device, it will send the data to this router, and through this here it will be sent to this, like this path will be followed for communication. Okay, so these are the 3 different types of the topologies that are supported in case of ZigBee. One is star, other one is mesh, other one is tree topology.